Docker networking. Using Docker, we have separated out the application and we have kept its environment limited to the container. But every service needs to connect with other services. For this, we have Docker networking. Hey friends, welcome back to the channel. If you are new here, my name is Mayank and I am a software developer. And on this channel, we explore the strategies and tools that are commonly used in DevOps. Today, we will be discussing about Docker networking. This video is helpful if you have some knowledge of Docker and containers. If you are just starting your Docker learning path, then I recommend to watch the video from the I button. That will help you in developing the basics of Docker, and then you can move on to this one. So first of all, what is Docker networking? Docker networking is a way of managing how containers communicate with each other. By default, Docker containers can communicate with each other on the same host, but not with the container on other hosts or with external networks. Docker networking enables us to connect containers with each other. There are several different types of Docker network. The first one is bridge network. In Docker, we have this default network which is called a bridge network that enables communication between the containers from the same host. Whenever a container is started with the default bridge network, it gets a unique IP address and it can communicate with other containers on the same network using the IP address. Let's try it out. Now I will check the default list of networks present. As you can see, we have 3 default networks present: bridge, host and none. So I will create a container named Bahubali. Now I am creating another container with the name Katappa. Now if I check the network, now when I have checked the default bridge network, I can see that there are 2 containers connected using this network. And if I try to ping one container from the other, let's try that. So using the exec command, you can go inside the container, and in the end I am writing the command which needs to be run inside the container. Now I will say if there is a ping is not there. Let's try to install ping. So as we can see that this is not able to resolve the name Katappa. Then we'll try to ping the IP address. As you can see, the containers are able to connect with each other. The next one is user-defined bridge network. As the name suggests, it is just a bridge network. So what is the advantage here? Whenever I define my own bridge network, I can add as many containers as I want in this one, and they will share the same network. In this way, I am separating out my default networks and a special network. And also with the default bridge network, the containers used to communicate with the IP addresses. But now when there is a user-defined network, they can communicate with each other just by the container name. Let's try it out. Now to try with the user-defined bridge network, I will create my own network. Let's say Docker. I will specify the driver as bridge and I will give the name Raja. I will remove the existing containers. Now I will try to create them again. Now when I try to create it again, I will specify the network as Raja, and I will do that same for Katappa. Now let's check the network. Okay, as you can see, I have 2 containers connecting with this one. Sudo docker exec. Okay, now I'll try to ping. So as you can see, this time it is able to resolve the other container, and also you can see that it is trying to ping katappa.raja. The next one is host network. As the name suggests, whenever a container is connected via host network, then the container will use all the network stack of the host machine. So whatever port the service is listening to inside the container will automatically be mapped to the port of the host machine. The main advantage of host networking mode is improved network performance, since the container is using the host network stack directly. However, this also means that the container shares the same network space as the host, which can be a security risk. Additionally, using host networking mode can limit the probability of the container since it relies on the specific network configuration of the host. Let's try the host network. Now if we try to inspect the container, so it is telling me that the PID which is running is 8688, and now I can check my host container, I mean the host where is it running. Now I can see that my Nginx is working locally. This is because I am using the host network which is mapping the port inside the container to my host machine. The main advantage of host networking mode is improved network performance since the container is using host's network stack directly. However, this also means that the container shares the same network namespace as the host, which can be a security risk. Additionally, using host networking mode can limit the probability of the container since it relies on the specific network configuration of the host. Next one is overlay network. Overlay network is a driver that enables communication between containers running on different hosts. This is useful for distributed applications that span multiple hosts or clusters. Currently, I have just a single host. Now let's try to create an overlay network. Now, when I try to create an overlay network, as you can see that I have just one node and this is not Docker Swarm, so I won't be able to use it. But in case you are using Docker Swarm or you have multiple nodes, then you can use this network to connect containers from multiple hosts. Next we have is Macvlan network. It is a network driver that allows containers to have their own MAC address on the network. This is useful for applications that require direct access to the network hardware or need to appear as separate devices on the network. But the main limitation here is your container and your host machine will be connected to the same port of your hardware. So this means your hardware must be able to support both the devices. Macvlan networking can cause security concerns since it is possible for containers to spoof MAC addresses and potentially disrupt network traffic. Let's try to create one. So to create a Macvlan network, I have to provide the subnet and then the gateway, basically the IP address of my machine. I need to write the gateway, which is the IP address of my router, and then I need to provide a parent, which is the network interface of my machine, and then the name of the network. And now I will create the container. I will name it Bahubali and I will provide the network name. Okay, now as you can see that my container Bahubali is connected with this network. The next one is IPvlan networking. Using this driver, it allows containers to have their own IP addresses on the network. This is useful for application that requires direct access to the network hardware or need to appear as separate devices on the network. But the main difference between Macvlan and IPvlan network driver is in the previous one, container is directly connected to the port of the router, but in this one, it is connected via the hardware of host machine. Creation of IPvlan network is same as that of Macvlan. So here, instead of my Macvlan driver, I will set it to IPvlan and I will rename it to my IPvlan network. Okay, now to connect it with the container, I will write the command docker run -d. I will just rename the network name and then I can use the same command. Your network is created and now I can check my network. This container Bahubali is connected with my IPvlan network and this has just the IP address but not the MAC address. This means this is not acting as a separate device but connected to the same MAC address of the host machine. And this is the subnet and gateway that we have provided while creating the network. And the last, the none network. As the name suggests, when you specifically define that your container should not be connected to any network, then this driver will be used. This can be useful for running containers that do not require any network access, such as containers that perform background tasks or run batch jobs. This is the network which is loved by the security guys because it is not connected to anything outside the container. Let's try the none network. Now when we inspect the network, we can check that there is a container and there is no MAC address or IP address associated with that container. I can understand if all this is overwhelming, but from a practical standpoint, if you know the basics of Docker, then you can jump towards learning the orchestration tools like Kubernetes or Docker Swarm. I might be wrong, but till now I have just used user-defined bridge networks in my practical experience. So you don't need to keep all this in mind and can always get back to this video or the documents